webcast, Improve Material Handling Efficiency and Cost Structures with Lithium-ion Batteries and Chargers. It's sponsored by Green Cubes Technology. My name is Dave Blanchard. I'm the Editor-in-Chief of Material Handling and Logistics, and I'll be the moderator for today's webinar. Before we get started, let me just briefly explain how you can participate in today's presentation. So first of all, if at any time you have audio difficulties or maybe the slides aren't advancing properly, if you'll just hit your F5 key, that refreshes your webcast console and typically will clear up any problems. If you're running pop-up blocking software, you will need to disable that to view this webinar. If you have any other technical difficulties during today's session, please press the question mark help button. You'll see that in the upper right corner to receive assistance in solving common issues. The webinar technology that we're using will allow you to resize the presentation. Just click the maximize icon in the upper right corner to enlarge the window. We welcome your participation during today's event. Simply type any question you might have into the Ask a Question window on the left side of your screen and then hit the Submit button. We'll be answering as many questions as possible during the Q&A session, which will follow the main presentation, but please feel free to send in your questions at any time and we'll add them to the queue. Please also be aware today's session is being recorded and it will be available on both the MH&L and the NED websites within the next day for you to review. You'll be notified by email just as soon as that archive is available. When the webinar ends, please take a moment, just a short moment, to complete the feedback form, and you'll see that appearing on your screen at the end. And that seems to be it for my housekeeping tips. Let me now welcome today's speakers. We have Robin Schneider, PhD, who's Director of Marketing with Green Cubes Technology. And joining Robin will be Jerry Crump, Director of Business Development, also at Green Cubes Technology. I'm going to now step aside and welcome Robin. Robin, the floor is now yours.
Thank you. So the title of our webcast today is Improving Material Handling Efficiency and Infrastructure with Lithium-ion Batteries and Fast Charging. First, I'm going to go over the agenda and the learning objectives. So you're going to learn how to implement opportunity charging and fast charging using the latest improvements in lithium-ion products, such as fast charge batteries, high power multi-voltage or multi-output chargers, and IoT capabilities. Opportunity charging is a practice applicable to all equipment from pallet jacks to forklifts and reach trucks, and it'll help you meet your throughput and safety goals. After a brief introduction to the company, I'm going to discuss some surveys and market research in the industry, and then we'll go into some generic comments about opportunity charging for both lead acid and lithium-ion batteries. Then Jerry's going to talk about our SAFEFLEX charger battery or chargers, and I'll talk about some specific multi-voltage batteries for fast charging. And then we'll look at remote management with the Internet of Things, how to improve safety with better battery technology, and how to quantify a reduced total cost of ownership. Just a bit about our company. Green Cubes designs and manufactures rechargeable lithium-ion battery solutions that are safe and accessible. Our solutions ease the migration away from lead acid and internal combustion engines and other older technologies. Our vision is to design platforms that accelerate the adoption of clean energy mediums. And a little bit more about Green Cubes. We've been around for about 30 years to help OEMs safely convert from lead acid systems to the right lithium technology for their operations. Among the many providers of lithium-ion solutions, we stand apart for our precision-engineered conversion of hand tools, electric vehicles, hospital systems, and telecom towers. Our reputation and years in the business stand behind us to keep us innovating and driving ahead. Right now, we have about 300 employees worldwide, and we have worldwide locations that have designed over 100 power systems in the last decade or so. In addition, in addition to our power systems innovation, we're focused on the utilization of remote monitoring and tracking to provide a solution not just across your system or site, but across your entire organization. There are 3 divisions within Green Cubes. Our industrial and medical power and automation group, using standard platforms and custom designs. Our network power, telecom backup platforms and then material handling and other motive industries. In this segment, we have a wide variety of battery products, charging systems, and remote management capabilities. And these, of course, will be the focus of today's presentation. Oops, sorry, skipped a slide. We offer more than 200 battery models for material handling equipment, including smaller Class 3 electric motor or hand rider trucks, Class 2 electric narrow aisle trucks, and Class 1 electric motor rider trucks for indoor use. We have a variety of communication protocols, charger models, sizes, and harnesses, and new models can be custom made and developed in about 12 weeks if that's required. So first, we're going to take a look at the state of the industry and some surveys and power trends. Recent surveys of the material handling industry show that most enterprises are focused on improving efficiencies, throughput, and workplace safety. Lithium-ion batteries paired with high-frequency and modular chargers can enhance an organization's ability to opportunity or fast charge without battery maintenance, reducing infrastructure costs, and eliminating a lot of common workplace hazards. Let's take a look at the results of these surveys and trends in the electrification of the material handling fleets. So this first slide is a survey that was done by Peerless Research Group for their readership, asking the question of how important these various issues are today for their organization. And in 2 years, how do they expect that importance to change? So we see the relative importance of different issues in the lighter blue and the dark blue, how important they expect those to be in a couple of years. And I've circled in green issues that can actually be addressed by the power infrastructure in the warehouse. So safety, of course, is a big issue, and older battery technology and combustion engines can present safety issues. Cost containment, so reducing the total cost of ownership of the power required to power your fleet is, of course, an issue contributing there. Cycle times and throughput, so asset utilization and the efficiency will contribute to those. And then, of course, farther down on the list is environmental sustainability, which is fairly far down on the list, but if you notice, it's the largest growing in terms of issue of importance. So that, of course, is something that is very much addressed by newer battery technology and the adoption of lithium-ion and other efficient charging platforms. This is another result from that same survey, just a little bit more detail. What you can see here is in the future, we're expecting a larger percentage of the spend in the material handling industry to be on infrastructure systems, and that is, of course, going to be related to the Internet of Things applications that we'll be discussing later in the presentation. And while the spend on material handling equipment is expected to go down a little bit, of course, lift trucks and accessories are the highest element in that overall spend. So there's a definite focus there because it's going to get the highest return in terms of bang for your buck if you are investing in that area in terms of return. So how are batteries related to efficiency, and what are the challenges in the utilization of batteries? And so why is it related to these things? First, there's a lot of problems in operator acceptance and misuse of the batteries. There's quite a lot of training involved in getting people to use them correctly, which means that you often end up with problems and downtime. In older battery technology like lead acid, there are long times for temperature stabilization and charging, which means that you often need more than one battery per truck. And those battery changes take quite a lot of time. The plugging in and unplugging of the batteries result in connector and cable damage, and they require a lot of part replacement and maintenance. And then you can have poor capacity and runtime match to how the battery and the truck is actually used for each individual operator and also throughout different equipment shifts. So both right-sizing the battery and monitoring its use will help with all of that. And then balancing equipment utilization from one truck to another is an area where batteries can help improve efficiency. So let's take a step back and look at what are the power sources available today for material handling equipment. So first, of course, there's internal combustion engines, which can be either propane or diesel. Of course, propane is sometimes used indoors, diesel not. Of course, these older combustion engines have high maintenance costs and emissions that preclude certain industries. And then, of course, the sustainability issues that accompany the use of propane and diesel, or burning fuel. And then lead acid batteries are the other incumbent technology. They have a relatively low purchase price, but they're generally only good for a single shift. They're low usage. They require regular watering and maintenance and monthly reporting to government agencies because of their environmental issues. And then they're also, they contribute to a lot of workplace injuries. And I'll discuss that a little bit more later. So what we see is a general adoption of lithium ion, replacing the lead acid. And that's the biggest shift in the industry today, because lithium ion is good for multi-shift applications. It has a very long run time, a low weight, small size. It can be fast charged or truly fast charged, where lead acid sometimes is advertised as fast charging, but it's not. And it's much more environmentally friendly. And finally, we have fuel cells gaining some traction, especially for very high volume applications, such as Amazon warehouses, where they have 200 or more forklifts on site, 24/7 operation. It takes a lot of infrastructure investment to get them up and running in a facility. So there's a high cost of installation that goes with them. So we don't see a lot of adoption of that. And that is reflected in this next slide, where you can see the adoption of these various technologies over the next, I guess, 6 years. So this goes from 2017, so it's got a little bit of a rear view, and to 2028 into the future. So furthest to the left, you have lead acid batteries with a slight decline in usage. The difference in the gray and blue here, if you're having trouble reading it, is the pre and post COVID estimates. So you can see there's not a lot of change in this particular application due to COVID. And then you can see the second grouping is the adoption of lithium ion over time. And you can see there's a huge increase in that. And then hydrogen or fuel cell applications see a very slight growth. And then internal combustion is relatively flat. This is another graph from that same analysis, a company called Interact that does these forward-looking power usage studies. And if you're wondering what these different adoption rates look like across different classes of lift trucks, there is high adoption across all classes. You can see here, class 3 is in the dark blue, class 1 is in the lighter blue, and then class 2 is in the gray. So class 1 and 3 have a very strong adoption of lithium ion. Class 2 is a little bit slower, but also very strong growth over the next 6 years or so. So if you total these, you're basically going to get to about half of all material handling batteries will become lithium in the next year or so. Okay, now we're going to look at opportunity charging. Opportunity and fast charging is a key differentiator for lithium ion because lithium ion can actually enable a true 24/7 nonstop operation of material handling equipment. However, typically fast charging requires specialized infrastructure and high power utility connections. For the batteries, you often need 2 battery cables to accommodate the current with larger batteries, and a bunch of workforce retraining in order to get them to adopt this type of practice. So we're going to talk about different technologies that can address all of those issues after we go through kind of the basics of opportunity charging of the different types of batteries available. So I'm sure most of the audience is aware of what the concept of opportunity charging is, but we'll just go over it briefly anyway. So essentially, you're taking advantage of a 1-hour charge time in the case of lithium ion, and for lead acid, you're basically forcing it into a faster charge than what it's really designed for. But essentially what happens is that the batteries are charged during short breaks at the operator's convenience. So if somebody goes to lunch or they have a coffee break or they're doing some other maintenance, they would charge the batteries then. It enables a 24/7 usage instead of dedicated charge times, where in the case of lead acid, typically what you would do is either swap out batteries or you would charge it overnight for a single daytime shift. Generally speaking, if opportunity charging is done correctly, it keeps the battery in the middle range state of charge, which is ideal for the battery's longevity and also would decrease the chance of an unexpected shutdown. So these graphs are the charging curves for both lead acid on the left and then lithium ion on the right. They're actually quite similar. So what you have is a constant current phase and then a top off with a constant voltage phase. And basically, the difference here is that the fast charging phase for the lithium ion battery is that it's mostly fast charge, where lead is only fast charged to about 80%. So it's only in that constant current phase for 80% or so, which is called the absorption phase. And then there's a much more slow constant voltage phase up to the 100% level. And for lithium ion, the charging efficiency approaches 100%, and more like 80 for lead acid. So there's a lot more energy loss for lead acid batteries. And this is true actually regardless of what's sometimes called a deep discharge battery or deep cycle lead acid battery. Lithium ion is just much, much more tolerant and forgiving. So you can get the full rated capacity and realize the full cycle life promise, even if you do relatively fast charging on it. So here's kind of a head-to-head comparison. So if you are going to charge lead acid appropriately, the batteries are discharged fully with each use. Then they're charged at a C/5 rate. So the C rate is the full capacity of the battery within an hour. So a C/5 rate basically means you do a full charge in 5 hours. Then there's supposed to be a rest period for about 8 hours and a cool down to equalize the temperature. The battery is supposed to be equalized on a weekly basis. There should be 1 full charge and 1 discharge per day. And in this case, you would get 500 to 1,000 cycles from a flooded lead acid battery. But opportunity charging for lead acid is typically 25 amps per 100 amp hour, or a C/4 rate, or fast charging, which is 50 amps per 100 amp hour, or a C/2 rate. So that's basically a 2-hour charge time. But these charge rates for lead acid often shorten or violate the manufacturing warranties. So if you need to change, often the battery would normally be warranted for, say, 5 years. And typically this would shorten it to some kind of prorated 2-year warranty. Lithium ion, on the other hand, regardless of the state of charge of the battery, it'll efficiently accept the power and increase its state of charge. It doesn't need to be equalized. It doesn't matter when. It doesn't matter its state of charge at the time. And then it can be immediately discharged and used. You can use 5%, you can use 90%. The battery really won't care. There's no need to cool or rest it after charging. And it'll accept a full charge in a little over an hour. And even with this kind of very, very strenuous usage that you would use for typical opportunity charging, you still get an exceptionally long cycle life of 2,000 to 4,000 cycles to reach about 80% of the original rated capacity, which is the definition of the end of life of a lithium-ion battery. And you would usually get the full warranty, the full 5 years, even if you're doing opportunity charging. So the best practices for opportunity charging, to do a power study to monitor the battery activity, to understand what your starting point is, and then determine whether there are adequate opportunities for charging throughout the shift. If there's no downtime for equipment, then the batteries will need to be charged an hour before the shift. If you need a second or third shift, then opportunity charging is often most appropriate. And if it's enabled by lithium, you can use decentralized charging stations to eliminate the operator's travel time from their work area to the battery maintenance room. You'd want to look at lead acid chargers to see if they're compatible with the lithium-ion batteries and assess the power output of the existing lead acid and lithium-ion charging infrastructure. And then look at the power rating on the charger to understand whether or not it's compatible with your usage and for opportunity charging. And then you'd consider a multi-voltage battery that I'm going to discuss later in the presentation if fast charging is enabled, but the battery, for a fast charging enabled battery, when opportunity charging is desired, but there's not even enough downtime in a shift to get a full hour and 15 minutes or so. And now I'm going to pass the presentation over to Jerry, who's going to talk specifically about our SAFEFLEX chargers and how they work in this type of scenario.
Good afternoon, everyone. Quick overview of the SAFEFLEX charger that Green Cubes is bringing to market. The SAFEFLEX charger will utilize CAN communication to automatically start and stop charging based upon the demand given by the SAFEFLEX lithium battery BMS. So this will be much more efficient charging than using older style BMIDs and such on a battery, lead acid battery. This allows also for smart and safe charging your MHE without manual input from the operators. So you don't have to worry about your operator hitting the start or stop button at the end of the charging. With a single input line needed for the ability to charge up to 3 pieces of MHE at a time, this greatly reduces the cost to install chargers in your facility. And that is through the elimination of multiple circuits, a circuit to each charger, and having to run and drop lines throughout the facility. With its modular design, you have the ability to start out with a 15 kilowatt or go up to a 30 kilowatt, depending on what your fleet needs are. And you don't have to invest in multiple chargers to cover possible voltage mixes within your fleet with this charger. Having the ability to detect and charge voltages from 20 to 120 volts allows for much greater operational flexibility and commonality of operation and spares such as cables within your facility. The SAFEFLEX charger is designed as a high frequency unit, allowing for it to be built in a very small package for the size of output that we're going to be able to deliver. This allows you to mount it in multiple fashions, either on the wall or on a stand or in other applications that are suitable for your needs, saving valuable real estate with your floor space if needed. And with the high efficiency of this charger at up to 97%, it'll actually lower your operation costs for recharging your MHE fleet. Like I said, we've talked about previously with Robin, fast charging. Unlike lead acid, lithium is equipped to take a 1C charge. This means that the SAFEFLEX charger can replace a large amount of energy used during a shift through opportunity charging, shift changes, breaks, and lunches. It's small and lightweight. Having a small and lightweight charger allows you to have many different configurations to install it within your facility. Wall mounting capability allows for it to be mounted on the wall and not take up valuable floor space within your facility. Same sizing of the modules, 15 or 30 kilowatt, allows you to buy the same looking charger, but have either one module or two, depending on what your needs are. It has up to 3 outputs that can be configured in 6 different configurations. We'll touch on that on the next slide. You have the ability to charge up to 3 batteries at the same time. Again, high efficiency rating of 97%. There's no input current distortion, so that will help with the load balancing within your facility. And one of the things we have on the roadmap is a version that will be IP55 that will allow you to actually install chargers outside the facility, again, leaving more room inside the facility for your operation. And this unit will have a color digital display with IoT communications capabilities. I won't go into all the configurations because you can get these slides at the end of this, but as you can see, these are the configurations that we have established for this charger. The outputs will be limited, however, by the kilowatt rating and the voltage of battery that you're using. This means a higher voltage, faster paced operation should be a candidate for a higher kilowatt unit so that you can maximize the transfer of energy back into your battery. More information can be found out through Green Cubes on this through requesting info on the website. As you can see, these units are built for multi-voltage inputs. This allows for you to use the same charger in operations in the US where we're 483 phase, or if you've got an operation that may be in another country that uses other inputs. These are 50 or 60 hertz units. That in itself is an advantage because you're able to have commonality of products being used across your network. And you're also able to use that IoT communications to pull data across network on the same platform. As you can see, this unit's very efficient, and when it's not in use as well, so as it's sitting there in standby mode, it won't be putting a large draw on your facility power. It comes with the ability to add it to your internal Wi-Fi or use a GSM for communication to pull the data off of the charger. It also has a wide range of operating temperatures to allow it to be placed in cold storage or in a hot warehouse. Same thing for the future growth of the IP55. It'll have a wide range of operating temperatures allowed for it. To switch gears just a little bit, I'll talk about another charging product that we have and in development, and that is our high-powered wireless charging. This is a 30 kilowatt wireless charger. This charger can be utilized in manual operated equipment or possible AGV applications. It allows for charging without cables to interface, which is often a failure point. Though it is not as efficient as the SAFEFLEX charger we just talked about at 97%, the 93% efficiency rating of this charger is still higher than many of the older chargers that we still find in operations today. As long as the operator parks within the allotted charging zone, it takes the human factors of plugging in the opportunity charger out of play, and it's going to be a really robust product for us. Robin, I'll go back over to you. Robin, I think you're muted.
Thank you. I thought I was an old pro at this, but apparently not. So right now I'm going to talk about fast charging of a very specific type of battery technology that'll get you to true opportunity charging from over an hour for lithium ion to under an hour. So we call this our multi-voltage technology, and you'll understand why in a second. First of all, our Lithium SAFEFLEX brand of batteries is a comprehensive battery solution designed to meet the cost, performance, and efficiency and durability requirements of the rugged warehouse environment. It includes application-specific cell chemistry and intelligent battery management electronics. They're maintenance-free and have very high cycle life for industrial vehicles, and are customizable features to fulfill the most demanding requirements. And they generally can be used as a drop-in replacement for lead-acid batteries. But this multi-voltage technology enables the battery to be charged at double its output voltage. And this, because it's constant power, actually cuts the charging time in half, and it makes opportunity charging a more accessible option when you have a really fast working warehouse. And it makes the simplicity and ease of use for the operator of lithium ion even more apparent. So multi-voltage technology enables the battery to charge at double its output voltage, like I said. The multi-voltage battery completes a full charge in less than an hour, and it's basically offered in 3 different couples. So a 24-volt battery with a 48-volt charge, a 36-volt battery with a 32-volt charge, and a 48-volt battery with a 96-volt charge. So you can see in this little graphic depiction, basically the multi-output charger that Jerry discussed would be putting out 96 volts to charge a 48-volt battery in half the normal charge time, or 72 volt charge for a 36 volt battery. And this also enables us to use a single 4-aught cable, which delivers cost efficiencies and minimizes the chance of cable damage, which, like Jerry said, is often a failure point for battery charger combinations. So this graph on the right depicts the different charge times for lead acid in the black, regular standard lithium or lithium SAFEFLEX batteries in the dark green, and then the multi-voltage in the light green. So for example, with a 30 kilowatt battery, you could have a 48 volt for 30 kilowatt hour, 48 volt, 600 amp hour battery. You could be fully charged in less than 1 hour at 320 amps. And just to put that in terms that you might be familiar with, a class 1 248521 battery would be fully charged in an hour over a single cable connection. So that's a really big improvement over any standard battery. And now some more detail about a feature that we've mentioned a little bit, which is the remote management with the Internet of Things. And this can improve asset utilization, service, and support. And these are features of GreenCube's batteries and charger systems. So what are we talking about here? So basically, this is the intelligent management of the smart system, and it can share with operators in the management team. They can watch the fleet remotely on site with a laptop or from some centralized computer system remotely. They can use this monitoring to right-size the batteries, resulting in the optimization of capital expenditures. They can also do real-time fleet management and optimize the operating expenditures. So basically what happens is the IoT-enabled batteries are on the forklift or pallet jack. They communicate with some kind of wireless gateway, which then communicates to a hub on site, and then goes to a customer web portal. And that portal will display all kinds of information real time or cumulative. It can be used for billing applications and all kinds of different things to basically improve asset utilization. And so let's look at an example of what that output looks like. So you can see here in the upper left corner, the different for this particular customer, the different locations that they have batteries and that are being monitored. So you can monitor the power consumption and the asset utilization of different trucks from all these different locations. You can see it real time on the bottom, and then you can see different power consumption over time on the top right. So during trials, performance data can be used to verify operator behavior and look at appropriately right-sizing the battery for purchasing decisions. And then you can look at optimizing it over time and making sure that your operators are using the batteries appropriately and sort of load level among different assets. Okay, so the improved safety features of lithium-ion versus lead-acid batteries. And how does this contribute to your infrastructure costs and that sort of thing? So maintenance for lead-acid batteries. The charging of lead-acid batteries is actually really hazardous, even though many workers may not remember this because it's kind of a routine activity for them. The three main risks are hydrogen gas formation when the battery is being charged, exposure to sulfuric acid from spills and leaks, and physical injuries from the battery's weight. because it does need to be changed generally. Repetitive use injuries such as sprains and strains are also commonly associated with battery changing. And the highly corrosive electrolytes in the batteries can cause respiratory irritation, eye damage, skin irritation, and they can even erode tooth enamel. And then the sheer size of material handling batteries means that crush injuries are also really common. This is an overview of the risky maintenance that's required for lead acid batteries. So maintaining the fluid levels, both overwatering and underwatering can damage the battery. And if there's too much water added, the electrolyte levels, skipped ahead a bit, can expand and cause the battery to overflow and damage the battery. The liquid or electrolyte is a combination of sulfuric acid and water. And the plates in a lead acid battery contain an active material that needs to be continuously bathed in electrolyte while oxygen and hydrogen gas are released during the charging. When the batteries are recharged, they generate hydrogen gas that's explosive, so the ventilation system in the warehouse needs to be adequate. The electrical voltage created by the batteries can ignite flammable materials and cause burns. In fact, workers have been injured and killed when loose or sparking battery connections ignited gasoline and solvent fumes during routine vehicle maintenance. Also, the personnel need to wear protective equipment, and they need to have splash goggles, a face shield, gloves, etc., which adds to some of their burden in changing and maintaining the batteries. And then you also need to have infrastructure for first aid in emergencies like eye wash stations and emergency showers, which add to some of the infrastructure costs associated with lead acid batteries. Lithium ion, on the other hand, is sophisticated, doesn't really require any maintenance. The batteries are sealed, as you can see in the picture on the right. Those are the cells that make up the inside of a lithium-ion battery. We use lithium iron phosphate technology, which is the safest. And I'll compare that to other types of lithium ion in the next slide. There is a separator inside a lithium ion battery also. And it can actually shut down any breach between the anode and the cathode layers. The electronics of the lithium-ion battery provide general protection against overcharge, over-discharge, high and low temperatures, and anything else that can contribute to a dangerous situation. And they're generally maintenance-free over the lifetime of the truck, which eliminates some of the possibility for user error and reduces risks. I'm not going to go through this slide in too much detail, but this is a comparison of lithium iron phosphate batteries that are used most often for material handling applications versus NMC, which is also known as mixed metal oxide, which contains nickel, manganese, and cobalt. The takeaway here is that lithium iron phosphate has a slight disadvantage over the nickel cobalt based chemistries in that it's a little bit bigger and heavier, but that doesn't really matter for material handling equipment. But it does have very, very long cycle life. It's very safe and it delivers very high power. So it's very well suited to material handling equipment. So a little bit about the environmental advantages of lithium-ion batteries. So they are very high capacity, long runtime batteries. And they have very high efficiency. They have reduced water consumption, no hazardous spill precautions. They use less material waste and scrap because of their higher life cycle. They have higher energy density and they can be reused for other applications. Lithium iron phosphate is non-toxic, non-contaminating, and has no rare metals. And actually, Iron is a relatively abundant ore, so if you've heard about any of the material shortages for batteries, that's not applicable to this. LFP chemistry is UL, CE, and RoHS approved. It's easy to dispose of because it has no heavy metals. And then it also can be recycled into other applications like energy storage. Now let's look at how all of these can be put together for a reduced total cost of ownership and how we can quantify that. So first, I'm just going to summarize the challenges of lead acid: normal maintenance, watering and cleaning the acid residue typical of flooded lead acid batteries, monitoring through a charger interface rather than from the battery directly, environmental and recycling issues and reporting, workplace injuries, long charge times and long cooling times, and then that they are low capacity and heavy and large, which isn't really that much of an advantage for material handling, but it could be in some cases. For lithium ion, it's a very low maintenance option, much longer cycle life. Can last up to 10 years, accept partial charges without degrading the battery life. Eliminates battery changing and workplace injuries. It has a long run time, faster charge time, can use remote monitoring and troubleshooting, has better cold temperature performance, and then the potential to reduce the number of trucks required if you use all of these things together for asset utilization. Now let's look at how you can quantify, this is our final topic, the Opex and CapEx improvements for lithium ion over lead acid. First, there are the capital expenditure gains brought by the features of these systems and optimized during the design with the IoT interface. Everything from the batteries themselves to the charging rooms can be right-sized. You eliminate battery handling rooms, ventilation accommodations, eyewash stations, and safety gear. You can reallocate battery handling rooms to other uses. And then there's operating costs. The increase in productivity and lower cost of operation can be improved by 30%. And the 1 hour charge time eliminates the need for battery changes and equilibration. There's lower electrical utility costs with both the battery and the charger being so efficient. Improved working conditions based on this, the safety improvements that I discussed, the improvements in environmental conditions, and improved asset utilization. And also with that new charger, you can distribute the chargers remotely and charge multiple trucks at a time. So if we plug all of this into a calculator and look at the improvements, this is an example for a cold storage application in Florida where the customer had 80 trucks. We look at this type of ROI analysis typically with our customers, and then after they've looked at their trial or evaluation, we can revise these calculations to do it specific to their usage. So this example is for an 80 truck fleet located in Florida. And there are a couple points here that I want to bring to your attention. Notice that the capital expenditure between lead acid and lithium is about the same over a 5-year period. The main difference is that lithium ion solution has a higher upfront expenditure on the battery assets, while the lead acid solution has the expenditure on lead acid batteries spread out over a 5-year period. The annual maintenance costs for propane versus lead acid are roughly the same at around $600,000 a year, while these maintenance costs are negligible for the lithium ion solution. And then the fuel cost for propane is relatively high. But the lithium ion batteries require less electrical energy for charging than an equivalent lead acid solution. And this lower power consumption from the higher efficiency of lithium ion. The net benefit in this case is about a $2.8 million CapEx and Opex saving over propane and a $4.2 million savings over lead acid solutions. And then for companies that have green initiatives underway, the propane and lead acid solutions generate an incremental 8 to 11 tons of carbon emissions over that 5-year period. So you may have some gains from that as well. So in conclusion, the benefits of lithium-ion solutions with our charger and IoT is decreased time-consuming battery and maintenance protocols, reduced workplace injuries, increased uptime. You can embrace and meet your green initiative goals, decreased electricity consumption, and the reduce of consumable equipment parts. And then the optimization of floor space and other infrastructure. And potentially you can reduce the number of trucks required. So all of this new technology that we're introducing makes Green Cubes a leader in power for material handling equipment. And we have about 10 minutes left for our question and answer period. So I'm going to turn it back over to our moderator.
Thank you, Robin. And Jerry, that was just a tremendous presentation. A few of you have already submitted questions, so we're going to jump right in just a quick second. As a reminder, please take a moment to complete the feedback form that will appear on your screen at the end of the webinar. So let me take the first question that came in. And if you haven't submitted a question yet, please go ahead and do so in the next 10 minutes. Any questions that we don't get to, by the way, we'll forward on to our presenters, so your questions could be answered offline. So first question, are the maintenance requirements for NMC the same as for LFP batteries?
Yes, so there are some batteries based on NMC for material handling equipment. Some of our competitors use that, but they are also low or no maintenance, but they don't have as good cycle life. And they don't have as good environmental repercussions, if you will. And they aren't as good at high power applications, so their cycle life tends to be a little bit lower. Those are the disadvantages, but the maintenance issue is the same.
Okay, thanks. This question is actually directed to you, Jerry. Can you discuss the charger's applicability to a highly mixed fleet with legacy lead acid products that are still in use?
Yeah, unfortunately, that's one of the things that we're going to see, right, is mixed fleets for some time. So we're developing this charger to have the ability to charge the lead acid batteries that may be sitting right next to your brand new SAFEFLEX lithium batteries. That should be rolling out about the same time that the charger hits market.
Okay. Our next question, the person writes, I hear a lot about fuel cells, but why aren't they gaining market share faster if we're hearing so much about them?
So fuel cells are a great technology. They basically use hydrogen and oxygen that's in the air to power equipment. So hydrogen is the fuel, and then it just reacts with oxygen and creates water. And so it's very, very environmentally friendly. It's also very efficient. Unfortunately, we don't have a so-called hydrogen economy yet. So the infrastructure costs required in order to get hydrogen fuel to the fleet is very high. So we only see it adopted in certain places where they have very, very high use and can afford a very, very, very high upfront cost. But I think that in the future, sometime 20 years maybe, what we'll see is fuel cells and lithium-ion batteries complementing each other much in the same way that internal combustion engines and lead acid batteries did in the past.
Interesting. Thank you. Let's go to a different kind of a question. This one's asking, when will the new chargers be made available to the public? And will they be sold through distributors?
Yeah, so the plan right now is to release the charger in Q2 of this year, towards the end of Q2. And yes, our distribution partners, we will be working with them to sell the chargers.
Okay. Why did you use cold storage as the usage example?
That's a great question. So cold storage is one of the early adopters of lithium technology because they have increased pain points with lead acid. Lead acid can't be charged in a cold environment. Also, the cold temperature will freeze the electrolyte, reducing the overall viable capacity of the lead acid battery. And to charge a lead acid battery, you need to take it out of the freezer, let it the temperature equilibrate, then charge it, then move it back in. And that represents some dangerous situations because you have condensation on the equipment. With our lithium-ion SAFEFLEX technology batteries, we actually incorporate heaters into the battery so that the battery can be charged at very, very cold temperature, which means that you can use the battery opportunity charging even in a freezer environment or outside in a very, very cold environment. And so we see companies that have cold applications being the first to implement lithium-ion opportunity charging in the industry.
Okay, thank you. The next question asks, what is the input voltage chargers and what is the tolerance?
Yeah, so the input voltage is between 346 and 480. Unfortunately, we don't have a solution day one for 600 volt. The tolerance, I would have to get back with that individual on what that is. Typically, it's 10%, but I don't know if that is exactly what they've got engineered into this model.
Okay, I'm just looking to see if we have any more. Yeah, we do have a new question. Is it really proof that a lithium-ion battery can last for 10 years? I guess maybe has it been proved that an lithium-ion battery can last for 10 years?
Yeah, so we have, so we started introducing lithium-ion batteries into the material handling market roughly 10 years ago, and we aren't getting, people repurchasing yet. So, I mean, we have firsthand knowledge of batteries lasting that long. And in fact, they can actually last somewhat longer. The 80% of the original capacity being defined as the end of life is actually somewhat arbitrary. So the lithium-ion battery does have some useful life in secondary applications and could be used for something like energy storage afterwards. So in fact, the lifetime of the battery is much longer.
Okay, we're almost at the top of the hour. We'll take one more question and then we'll wrap it up. Do lithium batteries or chargers need to be calibrated with a computer being on them?
No. So lithium batteries have a, what is the acronym is BMS, so a battery management system that basically self-calibrates over time and then communicates with the charger or through IoT to something else. But it is self-calibrating and you don't need to hook a computer up to do it.
Okay, thanks, Robin. There were a couple other questions. We're going to have Robin and Jerry follow up offline since we have hit the top of the hour. So let us just wrap it up. First of all, excellent presentation. I think our audience really Got a lot of great information. So let me thank our speakers, Robin Schneider and Jerry Crump, and our sponsor, Green Cubes Technology. On behalf of Material Handling and Logistics and New Equipment Digest, I'm Dave Blanchard. Have a great day and take care.